Here we have, for the second or third time, the complex conjugates theorem and also the irrational conjugates theorem. And they basically say something like this. If I had something like 2 plus 5i as a root, as a 0, I would say that I must also have its conjugate as a 0 as well. And if I had a similar situation down here, if I had 2 plus the square root of 5, then I would also have 2 minus the square root of 5. All right, the conjugates come together. They come in pairs, okay? So if you have one, that means you have the other. All right, so that's appropriate for what I have down here. I'm supposed to come up with a function, f, of least degree, don't overdo it, that has rational coefficients. I don't want anything like the square root of 6 out in front of x or something. That wouldn't be good. That's not rational. And a leading coefficient of 1. Thank you very much. That makes it nice. And the given zeros. Here are the given zeros. 3i. Well, if 3i is invited to the party, then minus 3i, its conjugate, is also coming. And because remember, we have we have a real number out in front. I know it's a 0. But over here, then, we'd have 0 minus 3i. So just because we don't write the real part doesn't mean that we don't still have a conjugate. And if I have 2 plus I and 2 minus I, then I must also have 2 plus I. These are things that don't come without their partners. All right, so let's go ahead and build this. We have x. Well, it's going to be some work, isn't it? We'll say we always subtract, so x minus 3i times x plus 3i times x minus 2 minus I, and we have x minus 2 plus I. Okay, I'm using the parentheses inside because it's always x minus the 0. Okay, I'll take care of this first one, and you know these are conjugates, so I won't get a middle term. I'll just focus on x times x is x squared, and negative 3 times positive 3 is negative 9, and I get I squared because there's 2 of them. Well, okay, you know that the I squared is a negative 1, so I can just say x squared plus 9 and get rid of the I. All right, now what happens with this next part? Well, again, I have conjugates, but not on the outside, so I'm going to get a middle term. The inside of the inside is not. You'll see. You'll know what I mean here. X times x. Well, that's the easy part. X squared, and then I'm going to have negative 2i. No, not 2i. 2 minus I. Well, I was going to try to, let's do it like this. No, let's not. Let me try something else here. Okay, I'll just go ahead and be honest about the whole thing. I was going to try to skate around here, but I better say this. 2 plus I times x, that's the outside. And then I'm going to say negative 2 minus I times x. Okay. And then these two together, I'm going to say plus something. Well, what happens, I better come off to the side here and say 2 minus I times 2 plus I. Because now I need to write it right there. I need the result. I need the last times the last, but the last is complicated because it's got its own binomials. So what's going to happen here? Well, I have 4, right? 2 times 2 is 4. I won't have a middle term, but I will have negative I squared, okay? And that's going to be a negative 1, so it's going to be a plus. When I put these together, I'll have a plus 5. So we'll go ahead here. We'll say x squared minus 2x minus xi minus 2x plus xi, that's going to go away. And then plus, this becomes 5, right? 4 plus 1, because the negative 1, negative, negative. Okay. So let's write this again. I guess we'll write it all out together. X squared plus 9. And then we have x squared. Then we have 2 x's. So we have negative 4x. The xi's go away. They cancel. And I have plus 5. Okay, so that's all cleaned up so far. And now I'm going to do my normal x squared times x squared times negative 4x, and x squared times 5. And I'm going to get x to the 4th minus 4x to the 3rd plus 5x squared. And then I'll come along here and I'll say 9x squared, line that up with the other x squared, negative 36x, and positive 45. And I'll add these up together, and I'll get my function. I'll say the f of x, they asked me for f, right? Yes, a function f is equal to x to the 4th minus 4x to the 3rd plus 14x squared minus 36x plus 45. All right. And here's the amazing thing about this function. It's not going to hit the x-axis anywhere, and I'll put up a graph of this. But we know that it's a positive. It's a positive out in front. Leading coefficient is positive, and the exponent is even. So it might be doing something like this. It might, but the x-axis will be down here. You know, I don't know where this happens, but it'll be something like that, because it's not going to go down far enough to touch the x-axis, so all of my zeros are imaginary.